AI could discover new laws of physics, but there's one surprising problem. Source: CISA Media Lab research published in the Journal of Cosmology and Astroparticle Physics, JCAP. What if artificial intelligence became so good at understanding the universe that it actually started missing entirely new discoveries? It sounds impossible. After all, AI is already transforming astronomy, helping scientists analyze billions of galaxies, map dark matter and search for clues about the origins of the cosmos. But a new study has uncovered an unexpected paradox. The very knowledge that makes AI incredibly powerful may also make it blind to the biggest scientific breakthroughs. In other words, an AI trained to recognize the universe as we know it might completely overlook evidence that the universe works differently. And that raises an important question. Can artificial intelligence truly discover new physics? Or does it first need to learn how to forget? To understand the problem, we first need to understand the biggest mystery in modern cosmology. Scientists currently describe the universe using a model called lambda-CDM, or Jogant-DM. This model explains an astonishing amount of what we observe. It describes how galaxies form, how the universe expands, and how matter is distributed across billions of light years. It has successfully predicted countless observations and has become the foundation of modern cosmology. But researchers know it isn't the complete story. The model depends on mysterious ingredients like dark matter and dark energy, substances that together make up about 95% of the universe, yet whose true nature remains unknown. Recent observations have also hinted at possible cracks in the model. Massive neutrinos, evolving dark energy, and even modifications to gravity itself could all represent entirely new physics waiting to be discovered. Testing these possibilities is incredibly difficult. Scientists create enormous computer simulations that generate entire virtual universes. Each simulation starts with different physical assumptions and involves billions of years of cosmic history. Researchers then compare these simulated universes with real astronomical observations. If a simulation matches reality better than the current model, it could point toward new laws of physics. There is just one problem. These simulations are unbelievably expensive. Some require massive supercomputers running for days or even weeks. Exploring thousands of different possibilities quickly becomes a computational nightmare. This is where artificial intelligence enters the picture. Researchers investigated a machine learning technique called transfer learning. The idea is surprisingly simple. Imagine you're studying advanced physics. Instead of immediately reading graduate-level textbooks, you first learn the fundamentals from an introductory course. Once you understand the basics, mastering more complex ideas becomes much easier. Transfer learning applies exactly the same principle. Instead of training an AI from scratch using the most expensive cosmological simulations, scientists first teach it using simpler simulations based on the standard model. After building this foundation, the AI is fine-tuned using more sophisticated simulations that include possible new physics. The results were remarkable. In some cases, researchers reduced the number of expensive simulations needed by more than a factor of 10. What once required thousands of simulations could potentially be accomplished with only a fraction of the computational cost. For cosmologists, this represents an enormous acceleration. But then, something unexpected happened. The AI became a victim of its own experience. Researchers discovered a phenomenon called negative transfer. The concept is surprisingly familiar. Imagine a doctor who has diagnosed thousands of cases of the common cold. One day, a patient arrives with a rare disease whose symptoms look almost identical. Because the doctor has seen the common illness so many times, there is a natural tendency to assume that's what they're seeing again. Experience becomes a bias. The AI behaved in exactly the same way. One of the team's experiments involved massive neutrinos. Neutrinos are incredibly tiny particles that pass through your body by trillions every second with almost no interaction. Although extremely light, they still possess mass, and that mass subtly influences how galaxies and cosmic structures form. Detecting these effects could reveal important new physics. However, the AI had a problem. The signatures produced by massive neutrinos looked remarkably similar to ordinary variations in an existing cosmological parameter called sigma-8, or UA, which measures how strongly matter clusters throughout the universe. Because the pre-trained network had spent so much time learning the standard model, it naturally interpreted these unfamiliar patterns as something it already knew. Instead of discovering something new, it confidently explained away the evidence. The AI wasn't making random mistakes. It was applying its previous knowledge too effectively, and that may be the most fascinating result of the entire study. The researchers emphasize that this behavior reflects a genuine physical challenge. Different laws of physics can sometimes produce almost identical observable effects. Even human scientists faced the same problem. Two completely different explanations may fit the same data. Artificial intelligence simply inherits that ambiguity. The danger is that an AI optimized for efficiency may become too attached to familiar patterns and fail to recognize the unexpected. Ironically, the better it learns the known universe, the harder it may become for it to discover an unknown one. Despite this limitation, the findings remain extremely encouraging. Transfer learning dramatically reduces computational costs and could become an essential tool for the next generation of astronomical surveys. Future observatories will collect unprecedented amounts of data, mapping billions of galaxies and probing the universe with extraordinary precision. Without AI, analyzing this information would be nearly impossible. But the study also delivers an important lesson. Artificial intelligence is not simply a machine that finds answers. It is a machine that finds patterns. And if those patterns become too familiar, genuine discoveries may hide in plain sight. Perhaps this reveals something profound about science itself. Some of history's greatest breakthroughs happened because someone questioned accepted ideas rather than reinforcing them. The same may be true for artificial intelligence. Building smarter machines may not simply require teaching them more. It may also require designing systems capable of recognizing when everything they know might be wrong, because somewhere inside the billions of galaxies waiting to be analyzed may be a tiny signal that doesn't fit any existing theory. And the future of physics may depend on whether an AI has the curiosity or the flexibility to notice it.